In this video, we're going to do two graphing examples of graphing exponential functions by transformations. We've learned how to do horizontal and vertical translations, and we've talked about stretches, compressions, and reflections that are vertical. So we're going to practice putting it all together and making a graph. So I am just going to zoom in. We have two examples here. It wants me to graph by transformations and then state the transformations, horizontal asymptote, whether it's increasing or decreasing, the y-intercept, the domain, and the range. So we're going to start with the first one here, which says y equals 2 times 3 to the x plus 1 minus 5. So when I look at the equation, how do I know this is an exponential? I can see that the x is in the exponent. That's how you know. So when you're doing these questions, the first thing you want to do is find the base, which doesn't sound like it should be that complicated, but sometimes it's a little tricky. So to find the base should be the part that the exponent is on, right? So the 3 here is going to be our base because it's the part with the exponent. So this has a base of 3, and I'm just going to write that down, that my base is 3 to the power of x. And that's going to come in handy when we actually start to graph here. So what I want to do is I want to identify my transformation, since it did ask me to do that. I see that I have a minus 5, I have a plus 1 in the bracket up here, and I have a 2 out front. The 3 is not a transformation. The 3 is the base of the function, so it doesn't really count when we're doing our transformations. So the negative 5 is going to take my graph and move it down 5. The number inside the bracket traditionally moves the graph left and right. So a plus 1 is going to take it to the left 1. That's a terrible looking one, and I didn't cross my T. All right. And then the 2 in front is going to be a stretch, a vertical stretch of 2. So I'm just going to put a V for vertical stretch of 2. We haven't learned of any other types of stretches, but later in this course, we will be learning about horizontal stretches. So sometimes it's a good idea to get in the habit of just indicating that it's vertical. Now the asymptote, we could graph first and then try to fill that in, but we have talked about how to find it out of the equation. So when you're looking for the asymptote, the number that moves the graph up and down also moves the asymptote up and down. And since the asymptote starts at 0, whatever you see as your k value is going to be your asymptote. So here my asymptote is going to be y equals negative 5. Now increasing and decreasing. The first part of this lesson talked about increasing and decreasing. I could graph it first, but I think I'd like to try to at least fill out some information if I can. So we look at the base. A whole number base like 3 tells me that my graph would start out being increasing. And then if it was a reflection, that would switch it to decreasing. But since it's not, it's actually just going to be increasing. All right, y-intercept. We can do our graph and see if we can figure out the y-intercept from there, or there is a way to calculate it. To find the y-intercept, you just sub in x equals 0 into your equation. So I would do 2 times 3 to the 0 plus 1 minus 5, and maybe I might do that just down here. So y equals 2 times 3 to the 0 plus 1 minus 5. 0 plus 1 is 1. So 2 times 3 to the 1 plus 5. Now 3 to the power of 1 is 3, and 2 times 3 is 6. So 6 plus 5 equals 11. So my y-intercept is going to be 11. Now domain and range, I think I'm going to wait until I've done the graph to fill those in. It'll be a little bit easier. So to graph these, we're actually going to make 2 tables of values. One of them is going to be for the base function, 3 to the power of x. And then the other one is going to be what we call a transformation table. So it's going to have all my transformations in it. So there is some space for us to use over on the side here. And they're not going to be huge tables. So I'm going to start with my base. and I'm going to have x and y, and this is going to be for y equals my base, which is 3 to the power of x. And then I'm going to have my transformation table for x and y. That's going to have what I'm actually going to graph. So we do the base separately. With the parabola, when we graphed quadratics, the parabola had a nice easy step pattern. But because every time our base number is different, sometimes it's a fraction, sometimes it's a whole number, sometimes it's a 2 or a 3 or a 7. So I don't have one step pattern that works for everything because the base is always changing depending on the question. So I always like to pick the numbers between -4 and 4. So I do -4, -3, -2, -1, 0, 1, 2, 3, and 4. And then all I do is 3 to the power of those numbers. So 3 to the power of 4 is 81. 3 to the power of 3 is 27. 3 squared is 9. 3 to the 1 is 3. Anything to the 0 is 1. 3 to the -1, a negative exponent makes a fraction. So actually, if I take 3 to the power of 1, I flip it over, I make it a fraction to get 1 over 3. Okay, -2, we take +2, flip it over, make it a fraction, so for 1 over 9. Same thing with the 3, I get 1 over 27. And for 4, 1 over 81. That's my basic table. We're not actually going to graph this part. This is just to help us do our transformations. So for the transformations, we said that the graph was going to go down 5. Now if we're moving down 5, that is a vertical thing. It is making us go down, so that would be on the y-axis. On the y-axis, we are going to subtract 5. We're going left 1, which is that way. So left 1 changes my x values, and it always does the opposite of what you would see. So if there's a +1 inside that bracket, we actually end up subtracting 1 from our x's. And then the vertical stretch of 2 is going to change my y values. When we stretch, we multiply, and if we compress, we divide. So a stretch of 2 means I'm going to multiply my y value by 2. So for the x, we are just going to subtract 1. And for the y values, we're going to multiply by 2 and then subtract 5. So, -4, take away 1, -5. -3, take away 1 is -4. -2, take away 1, -3. -1, take away 1 is -2. And you can definitely see that there's a pattern here. I like to check the last one just to make sure. So 4 take away 1 is 3, which is exactly what I expected it to be. Now the second one's a little trickier. Sometimes I will use a calculator to help me out. So I'm going to do that. 1 over 81. I just punch in 1 divided by 81 and then times 2. Order of operations says you have to multiply first and then subtract 5. I get that decimal. I'm going to round that to -4.98. And then 1 divided by 27 times 2 minus 5 is -4.93. 1 divided by 9 times 2 minus 5 is -4.78. 1 divided by 3 times 2, take away 5, is -4.33. 1 times 2 minus 5 is -3. 3 times 2 minus 5 is 1. 9 times 2 minus 5, oh, you can't even see that, is 13. 27 times 2 minus 5 is 49. And 81 times 2 minus 5 is 157. All right, so what we're going to do is plot those on the graph. We're not going to put the pink one on, we're just going to do the blues. And I'm going to start with the numbers, the whole numbers on the bottom and work my way up. Obviously, some of these are not going to fit, like 157 is way too large. So if I've got my grid, first thing I like to do is a scale. It'll just take me a second. Okay, so on my table, I'm going to take all of those points from my table of values and plot them. So we can't see them both at the same time. I'm just going to let you watch the grid and then we'll put our points on. So 157 is way too large. My graph only goes up to 20. So 49 is also too big, but I can fit 1 and 13. And then 0 and 1. And then -1 and -3. -2 and -4.33. That one is going to be just below the -4 marker. And then -3 and -4.78, that should be closer to -5. And then -4.93 is really close to -5. And then -4.98 is really, really, really close to -5. And then I'm going to connect my dots. And when I'm taking a look at my graph, I notice that I have all of these numbers that are these decimals that keep getting closer and closer together, right? And they're getting closer and closer to a value of -5. We said the asymptote was -5 from the equation, plus I see from the table of values, these are getting closer and closer and closer to -5. So that tells me that my graph has an asymptote at -5, which means my graph is not going to cross that -5 line. Okay, so what I would like you to do is to, we need to do domain and range, and then I'm going to ask you to do the next graph on your own, and then we'll check in. So for the domain for this one, if I take a look at domain, that's the set of x values. So we usually start with xer to say that x is a real number. We put on those fun curly brackets. And then we look at the x values that we have going on here. So I see that this end of the graph is going all the way out. So the last value I have on my graph here is -18, but the graph doesn't stop at -18. It keeps going to -20, -2000, -8 million. It heads all the way off to the smallest possible negative number, which would be -infinity. And then on the other side, it does look like my graph kind of stops. The last real point I have is at 1, but it does just keep going and going and going and going. So it actually heads up all the way to +infinity. So we say that the x values are every number between -infinity and +infinity. X is all of those numbers in between. And then because infinity isn't really a number, I'm going to point the less than signs towards the smallest one, which is the -infinity. Right? But I don't put the equal sign on because you can't ever really get to infinity. So for the range, it's the set of y values. So we start by saying that y is a real number, so yer. And then we do the same thing. We look for the lowest number and the highest number. So I see that the graph is not going below -5, right? And at the top, my last point was at 13, but you know from the table of values we were already at 157. So this is just going to continue going up all the way to infinity. So our values are all the numbers between -5 and +infinity. So I say that it's all the numbers between -5 and +infinity. Y is all the numbers in between. And the arrow should always point towards the smaller number. So -5 is clearly smaller than infinity. Now I don't put the line on infinity because infinity doesn't really exist. And I don't put the line on the -5 because it never quite gets to the asymptote. It's just going to get to 4.99999. So take a second, try graphing the other one. If you don't need to do it, you don't need to watch the next part of the video, but I will show you how to graph that one if you need it.